Algebra 2, Lesson 26, Part A is about trinomial factoring. And before we start factoring, we're going to multiply binomials and look for the patterns. So I have 3 problems up here in this space at the top. We're going to go ahead and FOIL. First times first, x squared. Outer, negative 4x. Inner, positive 3x. Last, negative 12, so minus 12. Add the like terms. The 1 is optional in here, but I included that just because of looking for patterns with the numbers after we're done with these. And here, first times first, outer is 6x, inner is negative 2x, and then last is minus 12. Add the like terms here. And over here on the end, we have x minus 1 times x minus 12. First times first, x squared. Outer is negative 12x. Inner is negative 1x. Last times last, positive 12, because of the same sign. Add the like terms. And there we are. Okay, in the first two, the numbers were opposite signs. We got a negative last term because we're multiplying those two numbers to get this. Opposite signs when we multiply gives us a negative. Same sign gives us a positive. Would have been the same if these were both plus. We'd have a positive 12 here. For the middle terms, because those were opposite signs, we end up subtracting. And the sign matches the sign of whichever one was larger. The absolute value is larger. Over here where they're both negative, of course they're the same sign, so we add and keep the sign. Okay, so we're going to use those patterns for when we factor. And the first thing we want to do with these trinomials is make sure they're in standard form, which is descending order of the exponents. Start with the highest one and keep working your way down. So first thing, I'm rearranging this, x squared minus 5x plus 6. Always when I'm factoring, the first thing I want to check is for greatest common factor. If it has one of them, we factor that out first. There is none for this, so we'll go ahead and set up for the binomials. We know we need x times x to get the x squared, and now we need factors of 6. 1 and 6, or 2 and 3, that we add because they're going to be the same sign, so we'll be adding them to get 5. So 2 and 3. And they're going to be the same sign, but the sign has to match the middle term, so they're both minus. And I'm going to go ahead and FOIL this to make sure I have it right. X times x, x squared. Outer is negative 3x. Inner is negative 2x. Last is 6. Okay? When I add the like terms, I get a negative 5x. Totally matches what we started with, so I know it's right. Okay? On example 2, they're already in the right order. And there is not a greatest common factor, but I also want that lead coefficient. So the coefficient of the first term, I want that to be positive. So, and it isn't. So we're going to factor in negative 1 out of this, which is going to change all the signs inside here. Change all the signs. The whole reason was to not have a negative x squared. Okay, so x squared, and then this will be positive, and that will be negative, and I'm going to distribute, make sure I don't have this messed up. Negative 1 times x squared, negative x squared. Negative 1 times 5x, negative 5x. Negative 1 times negative 14, positive 14. Okay, so we've taken the negative out. All right, now, and you can't ignore that, that is one of our factors, so that has to come along. And now to get the x squared, we have those x's. I need factors of 14, so either 1 and 14 or 2 and 7. That I subtract because they're going to be opposite signs to get 5. so 2 and 7. And they're opposite signs, like I said. The larger of these has to have the same sign as that middle term, so plus 7. And they're opposite signs, so then the 2's got to be negative. And at least in my head, I want to FOIL this to make sure it matches. X squared, we have a positive 7x and a negative 2x. 7 minus 2 is 5x. And then opposite signs, so negative 14. It's good. Okay, next. These are not in the right order. We need to get them rearranged. Highest exponent first. Make sure you don't lose track of your signs. Negative 3x squared, positive 6x, positive 24. Okay, we can't have the lead coefficient negative, so we're going to take a negative out. But also, 3, 6, and 24, there's a GCF. Okay, so we're actually factoring a negative 3 out of this one. Okay, make sure we have it right. Negative 3x squared plus 6x plus 24. Okay, so there's our negative 3. There's our x squared. Now I need factors of 8 that I subtract, because they're going to be opposite signs again, to get 2. So it's 2 and 4. Okay, they're opposite signs. The larger is negative. We're going to FOIL x squared. There's minus 4x plus a 2x. That's minus 2x and then minus 8. It's good. Okay, one more down here. Alright, so it's not in the right order again. Highest exponent here would be the 4. Negative 2x to the 4th. The next highest one will be the 3, plus 12x to the 3rd, and then plus 32x squared. Can't have the lead coefficient being negative. Just makes things complicated. And then we look for the GCF. For the numbers, it's a 2. They all have some x's. When you're doing greatest common factor, you're looking for the lowest exponent. So x squared, that's how many they have in common, is 2 of them. Okay, and then what do I take times this to get the first term? X squared. What do I take times this to get that term? Well, negative 6x. And then for the last one, 2 times 16 gives me 32, and we already have the x squared. Okay, double checking by distributing. Negative 2x to the 4th plus 12x to the 3rd plus 32x squared. Okay, so far so good. There's the GCF. Now we're set up for the binomials. Alright, we're looking for factors of 16. 1 and 16, 2 and 8, or 4 and 4. So we subtract, because they will be opposite signs, and get 6. Okay, 15, that's 0, it's this one, 2 and 8. And opposite signs, the larger one is negative. Let's FOIL x squared. Minus 8x plus 2x is minus 6x minus 16. It works. We're done with that. Okay. I think these are a lot of fun. I hope you do too. It is very useful for many things we're going to be doing in the future. So make sure you are careful when you're factoring them. Okay. Part B is overlapping right triangles. We've already worked with similar triangles. And these are similar, but also they're right triangles. So there's just more we can do with these, because you know about the Pythagorean theorem. We'll be using that. Okay. Because they're overlapping like this, we know they're similar because they share this angle, and they're both right triangles, so they each have a 90-degree angle. That means this other one here, those two angles have to also be congruent because every triangle adds up to the same amount. So these are similar. That means their corresponding sides are proportional. If you prefer scale factor, you can use that. If you prefer proportions, you can use them. They both work every time. But again, because we have right triangles, we'll probably also be doing the Pythagorean theorem. First thing I'm going to do, like before, is draw both of the triangles separately. And you don't have to have them to scale. They should look close to being right triangles. Just I have a rough sketch. And my smaller one here on the left, the bottom side is 6, the vertical side is a 4, and the hypotenuse is A. On the larger one, the overall one, the vertical side is C, the bottom is 10. This is why I recommend redrawing them and labeling. When people get in a hurry, they'll frequently say the bottom side of the big triangle is 4, even though it's definitely larger than that. Oh, this one's 6, the other one's 4. No, it's the whole bottom. Good to redraw them and label things. The hypotenuse is A plus B. Okay, now we have our drawings. We can just look at them while we're working, and A is pretty straightforward to get using the Pythagorean theorem. We know that is A squared plus B squared equals C squared. Don't let it confuse you. A is our C in the formula. It's the hypotenuse. Okay, we have 4 squared plus 6 squared equals the hypotenuse squared. So capital A squared. Okay, and then we just simplify this side. 16 plus 36 equals A squared. 30, 40, 52 equals A squared. All right, that will simplify a little bit. This is, 2 times 26, but 26 is even. This is 4 times 13. So A is the square root of 52, but that is the square root of 4 times the square root of 13. It's 40 plus 12 is 52. Okay, square root of 4 is 2. So A is 2 root 13. I'm making this look like it takes a lot of space, and I have plenty of room to work with, so I'm kind of spreading out. But that's A. We still have B and C to find, and I'm going to go for C first. And I guess I'm going to demonstrate scale factor for this one and then proportion for the other one. Okay, you can use like scale factor for both of the two sides that are still missing, or you could also do, either one, scale factor, proportion. You don't have to mix them up. If we're doing scale factor, what do we take times 6 to get 10, and that's what we'll take times 4 to get C. So 6 times the scale factor, going from this triangle to that one, that's why the arrow, will give me this side, which is 10. I would divide both sides by 6. That means the scale factor is 5/3, reducing that. So I would take that scale factor times the 4, and that gives me C. Okay, so 4, this side, times the scale factor will give me that side. So 4 times 5/3 will give me C, and that means C is 20 over 3. Okay. Now for B, let's take a look at our drawings again. You have yours on your paper, but slide this down a little. Okay, to get B, we're going to have to use this hypotenuse, which really is A plus B. And I'm going to do a proportion for this one, even though I already know what the scale factor is, just to demonstrate that. So we could have a over 6 equals a plus b over 10, which I'm going to go ahead and write here. A over 6, hypotenuse over bottom, equals hypotenuse over bottom of the other triangle, a plus b over 10. Okay, and I do know what a is, so I could put it in now, or I can simplify this equation a little bit and then put it in. That's entirely up to you what order you'd like to do them. And I think I'm just going to keep my a in for a little while. So cross multiplying, I have 10 times a. Okay, and please keep in mind, cross multiplying is just a shortcut for multiplying twice. We multiply both sides by 6, and then we multiply both sides by 10. And we get this equation. 10 times a equals 6 times them. So 6a plus 6b. Alright, so I guess I'll go ahead and put my number in here for a. We have 10 times 2 root 13 equals 6 times 2 root 13 plus 6b. And as long as I remember which one I'm solving for, I could have kept the a in there for now and just gotten b by itself and then plug in the 2 root 13. That would keep the work streamlined a little bit. But if you put it in, then you're not forgetting which variable you're getting by itself. Okay, so we have 20 root 13 equals 12 root 13 plus 6b. And then we subtract 12 root 13 from both sides. 20 minus 12 is 8. 8 root 13 equals 6b. Divide both sides by the coefficient. So 8 root 13 over 6, and that reduces. 8 and 6 are both even. So b equals 4 root 13 over 3. And we are now done with that problem. I hope you have fun with these things.